In 3.4, we're going to introduce something brand new that you haven't really done before, but you've kind of done a little bit of it. It's called a proof, and we're going to do a bunch of examples for you. And this is the one thing that if you were to go home and say, yeah, in geometry we learned proofs, your parents will probably remember that the hardest part of geometry were things called proofs. But that's because they didn't have somebody like me who thoroughly understands it and can explain it in such a way that it's going to be like the easiest thing that you've ever done, right? Before we get into those things called proofs, we need to cover a concept that is called the corresponding parts of congruent triangles are congruent. There's an abbreviation for this really, really long thing called CPCTC. CPCTC stands for the corresponding parts of congruent triangles are congruent. And the whole reason that you learned how to prove two triangles are congruent to each other with the shortcuts from section 2 and section 3 is so that we can use their corresponding parts are also going to be the same. Let me explain with the picture. If I had a triangle that was 10 inches long. This is 10 inches. I'm just going to say it's 10 inches. And there's an angle. I'm going to call it 45 degrees. I measure it. And then I measure another side, and it is 12 inches long. And then I draw another 10 inches long piece. And then next to that 10-inch piece, I make sure there's a 45-degree angle. And then I make sure that there is a 12-inch piece connected to that 45-degree angle. If you have a side that's 10 inches and an angle that's attached to that 10-inch side that's 45 degrees and a 12-inch side, then what you know, how many triangles, if I were to draw another 10-inch and 45 and 12, how many triangles can you really make with a side and an angle and a side? How many triangles can I make that will have those same exact specifications? Are these going to be congruent to each other?
Yes.
Is that triangle going to be the same as that triangle? Exactly. You learned a shortcut in a previous section called side angle side that says if I have a side angle side that is congruent to another side angle side, then those two triangles are going to be congruent. What we're going to add today is that if I know that the two triangles are congruent, then their parts are also going to be the same. For example, this angle here is going to be the same as this angle there. Their parts are also going to be the same. If I want to prove that this part here is the same as this part there, I can use side angle side to prove the triangles are congruent, and then I can use CPCTC to prove that their sides are also the same. That's what this thing says. That the corresponding parts of congruent triangles are also going to be congruent. Meaning, once I know the two triangles are the same, then all their angles and all their sides are also going to be the same. So if I'm doing a proof and I need to prove that this side is the same as this side, I can prove the triangles are congruent by one of these methods and then use CPCTC to prove that the two triangles are congruent. That's the big idea. That's what it stands for. So that brings us to the proofs. And the proofs are problems where the solution is already known. They are going to give you some information and they're going to give you what the answer is. And your job will be to prove logically how did they get there, what information did they use. And some of these proofs are going to be pre-started for you. That's because you've never done them before, and so filling in the blank will be kind of easier for some of you to start with. And then by the time we're done, you're going to be given something, and then we're going to write out our own proof to prove things. So, this is what we wrote down. Most proofs start off with a given statement and has the word given as the reason. We're going to prove any other congruent parts we know and add marks to our drawing. And lastly, or thirdly, we're going to prove the triangle is congruent using the shortcuts. The last statement is what we're trying to prove. And if we're proving congruent parts, our last reason will be CPCTC. Everything else we do are examples. If you want to pull out your textbook, you can do this in the textbook if you would like. This is problem number 2 in your textbook for this assignment. This is a 2-column proof where you have a statement in one column and a reason in the other column. In this class, we are going to start off most proofs with our given is our reason. The word given is kind of like you can assume this. This is the given information. This is what you start with. Given, in other words, is your starting information that you can use. What's given to us? Side OM is congruent to side ER. Your textbook authors, this is the one thing I have a complaint about. Your textbook authors will put the congruent marks in the drawing for you. If it was me and I was making this worksheet, your drawing would not have those congruent marks. You would have to take the given information and add it to your drawing. I believe the people who write your math tests agree with me, and so be prepared to have to add that information to your picture when you read it. Side OM is congruent to side ER. Segment ME is congruent to segment RO, and since it's the second side, they have a double and a double for both of those. That is the first statement. Why do we know this? What is the reason why we know that this to be true? Why do we know it's true? It's because of one thing, because it was given. That's our first reason. We fill that in. There was something that you learned in either Advanced Math 8 or in Math 1 called the reflexive property. The reflexive property, if you have forgotten, you're going to need to write down what it is in your notes. The reflexive property is when something is congruent to itself. I'm just going to draw a little arrow. When something is congruent to itself, let's say like a box is congruent to a box, because it could be an angle is congruent to itself, this angle is congruent to itself, or this side is congruent to itself. What we're trying to do is we're going to try to prove that these two triangles are congruent to each other. We have a side and a side in this triangle. We have a side and a side in this triangle. But there's something that's shared, and there's something that is the same in both triangles. Do you see the letters? If you know what the two letters are that are the same in both triangles, say those letters out loud. O-E. And then I'm going to write that as a segment or a side. Segment OE is congruent to itself. Segment OE. What proves that something is the same as itself? The reflexive property of congruence. You can say reflexive property for short. What that does is that allows me to know that this third side is the same in both triangles. So I can add that to my drawing. Then the third statement says triangle OME is congruent to triangle ERO. And how do we know that these two triangles are congruent? We're going to use something from 3.2 and 3.3. If you know what the three letters that we're going to use are, say them out loud. And then what we do, well, And then what we do, we look at what we're trying to prove. We're trying to prove that angle M is congruent to angle R. That's what we're trying to prove anyways. That's our fourth step, our fourth statement. I have now, let me just kind of walk you through this real quick before I even get to this thing. We have proven that this side is congruent to this side. That's our first side. That was given to us. We did the second side congruent to the second side. That was given to us. We had side and side. Then we had OE was the same as OE, which was our third side. Now we can say the two triangles are congruent by side, side, side. And now we're trying to prove that this angle is congruent to that angle. We know that they have to be the same as each other because of 5 letters. Do you know what those 5 letters are? Say them out loud if you do. Because the corresponding parts, these triangles are congruent, so their parts have to be congruent. That's what CPCTC stands for. Corresponding parts of congruent triangles are congruent. Since the triangles are congruent, their parts have to be the same. That's a proof. It's not hard. It's logical. The hard part for your parents was, well, they give you this. How do you know what to do next? You basically are building something that's going to prove the triangle's congruent, and then you can say that their parts also have to be the same. Okay? Let's do another example. We'll do a little bit more this time. This is number 9. Number 9 says the given statement is YT is congruent to YP, and angle C is congruent to angle R, and angle T is congruent to angle P. The textbook authors, they assume that we will help you out and we'll put that into the picture. Don't assume that I'm going to do that on any quiz or any test. On any quiz or test, you'll have to do that information and put it in the picture. But I'm hoping that you know what your first statement would be. I'm hoping you know what's going to go here. If this is what you're starting with, then guess what? That's what you start your statement with. Whatever follows this word is what you write for your first statement. So what I would recommend to you is that you actually just write YT has to be congruent to YP, segment YP. Angle C has to be congruent to angle R, and angle T has to be congruent to angle P. Some people, when they write their proofs, will actually have this first idea as the first statement. Some people will put this as a second statement, and some people will put this as the third statement. And all 3 reasons would be given, given, given. But because Mr. Promo is a little bit, efficient, not lazy, but efficient, he's going to put all 3 on the same one, and he's going to say the reason is given. If you wanted to, you could actually split these 3 things up and have it as 1, 2, 3, and you can have it as given, given, given if you would like. It's not a big deal. Then the very second thing that it has, it says triangle CTY is congruent to triangle RPY, and it's asking for a reason. Why do we know that those 2 things are congruent to each other? If you know, say the letters out loud. I heard most of you say AAS. You have an angle next to another angle and the non-included side. An angle next to another angle and the non-included side. That's how you can prove that these 2 triangles are congruent to each other. So we start off with the given, then we prove that the triangles are congruent to each other, but what we're trying to prove is this. we're trying to prove that segment CT is congruent to segment RP, meaning this side is congruent to this side. We're trying to prove that. What could we use now that would be our closing reason as to why those things are congruent to each other? The corresponding parts of congruent triangles are congruent. CPC, TC. That's a proof. Proofs aren't hard. They're logical. They have steps to them. That's all you got to do. The hardest part really is coming up with the logical order of things. Last example is number 11, and then we'll be done with your notes. Number 11 says, copy and mark the figure to show the given information. Yay, finally. They finally don't put it in the picture for you. Explain how you would prove that angle P is congruent to angle Q. Now, you do not have to give this as a formal proof. It does not have to be a two-column proof, but what you'll see is I'm going to pretty much make it very similar to a formal two-column proof by doing things in steps and giving you reasons why we can do them. Given. For number 11, because there's going to be a different given statement for number 10, there's going to be a different given statement for number 12, we can only assume that KL is the perpendicular bisector of PQ. That's the only thing we can assume. Okay? So, this is our given statement. Because this is not a formal two-column proof, I don't need to start with that. If KL is the perpendicular bisector of PQ, then I'm going to use this word, bisector. If it bisects something, you learn that word in either Advanced Math 8 or in Math 1. Bisector means it cuts it into two congruent pieces. It goes through something at its midpoint. That goes through the midpoint. That means two pieces are going to be the same. What two pieces are going to be the same? How about this piece and this piece? PL would be congruent to LQ. Segment LQ, Mr. Paramo. Thank you. By? How come? How come PL is congruent to LQ? It's because of this word. I'm using this word's definition. I'm using the definition of the word bisector. A bisector goes through something's midpoint. Because it goes through the midpoint, these two pieces have to be congruent to each other. The next thing that I would do is I would start making a statement about these angles. Angle PLK and angle QLK are right angles. Angle PLK and QLK are right angles. How do I know that? What word am I using? Is this word right here. By the definition of perpendicular. And there's a symbol for that. If you don't know what that symbol is, it's an upside down T. That way you don't have to write out that whole word. We'll actually put that in our notes in the next section. But I'll just use it right now. It's a little early, but that's okay. Angle PLK and angle QLK are right angles. Why do I know that they're right angles? Because of the definition of the word perpendicular. KL is a perpendicular bisector of PQ. You learned about perpendicular bisectors in Math 1 or Advanced Math 8. That's where you got a compass and you had to draw a construction of something and from this side and a compass and you drew something through the two arcs. Those were perpendicular bisectors. PLK and QLK are right angles by the definition of the word perpendicular. Now what we're going to do is we've said they're right angles. Now I can say angle PLK is congruent to angle QLK. The reason I do this step is because I've used the definition of perpendicular, but I didn't say that these two things were congruent to each other. When I say that they're congruent to each other, now I have an extra angle that's the same. How do I know this? Because all right angles are congruent to each other. If I have one right angle, that's going to be always congruent or equal to another right angle. All right angles are congruent. And now what you have is a side and an angle that matches in both. We need another thing to use one of the shortcuts to prove that the triangles are congruent. Do you see something that is shared? Do you see something that is the same as itself? If you see it, say the two letters out loud. KL. Is congruent to KL. We just used a property in a previous proof. That when we say segment KL is congruent to segment KL, it's by which property? Reflexive property of congruence. That gives you a second side that proves that those are congruent to each other. Now what I can do is prove that this triangle PLK, now I'm using triangle symbol, the triangle PLK is congruent to triangle QLK by which of the shortcuts can I use now? Awesome. SAS. I had to prove that the sides were the same, the angles were the same, and the other side was the same. Now I can use SAS. Now the triangles are the same, and I'm trying to prove that angle P is congruent to angle Q. Now that I've proven that the triangles are congruent, what can I use that will prove that their parts are going to be the same? And that's how a proof is made. That's how you do your proofs. And this wasn't a formal proof. Otherwise, I would number everything. 1, 1, 2, 2, 3, 3. That's a formal two-column proof. This one, it didn't say to do that, so I'm just kind of lining it up as to how it would be if you wanted to do a formal two-column proof. You could. I'm going to stop your notes right there.